Myself, Mrs. Satabdi Dhar, and in this video, I'm going to discuss with you about the structure of operating system. In Unit 2 of operating system, that is operating system structures, we are going to discuss about system components. Those are process management, main memory management, file management, input-output system management, secondary storage management. Next is operating system services. Next, system calls. Uses of system calls, process control, file management, device management, information maintenance, and communication. Next is operating system structures. Those structures are simple structure, layered, monolithic structure, microkernel structure. Next is booting, and the last one is virtual machine. Now we will discuss about what is those system components. An operating system provides the environment within which programs are executed. To construct such an environment, the system is partitioned into small modules with a well-defined interface. The design of a new operating system is a major task. It is very important that the goals of the system be well defined before the design begins. The type of system desired is the foundation for choices between various algorithms and strategies that will be necessary. A system as large and complex as an operating system can only be created by partitioning it into smaller pieces. These pieces should be a well-defined portion of the system, which carefully define inputs, outputs, and functions. Although Mac, Unix, Linux, Windows, and other OS do not have the same structure, most of the operating systems share similar OS system components like file, process, memory, input-output device management. Now, the components we are going to learn are file management, process management, network management, main memory management, secondary storage management, security management, and input-output device management. We will discuss elaborately about this management in next upcoming slides. Now the first one is file management. File management is one of the most visible services of an operating system. Computers can store information in several different physical forms. Magnetic tape, disk, and RAM are the most common forms. Each of these devices has its own characteristics and physical organization. For convenient use of the computer system, the operating system provides a uniform logical view of information storage. The operating system abstracts from the physical properties of its storage devices to define a logical storage unit. The files are mapped by the operating system onto physical devices. You know that a file is a collection of related information defined by its creator. Commonly, files represent programs, both sources and object forms, and data. Data files may be numeric, alphabetic, or alphanumeric. Files may be free form, such as text files, or may be rigidly formatted. In general, a file is a sequence of bits, bytes, lines, or records whose meaning is defined by its creator and user. It is a very general concept. The operating system implements the abstract concept of the file by managing mass storage devices such as types and disks. Also, files are normally organized into directories to ease their use. Finally, when multiple users have access to files, it may be desired to control by whom and in what ways files may be accessed. The function of file management in OS are file and directory creation and deletion. For manipulating files and directories, mapping files onto secondary storage, and backup files on stable storage media. The next one is process management. The CPU executes a large number of programs while its main concern is the execution of user programs. The CPU is also needed for other system activities. These activities are called processes. A process is a program in execution. Typically, a batch job is a process. A time-shared user program is a process. A system task such as spooling is also a process. For now, a process may be considered as a job or a time-shared program, but the concept is actually more general. In general, a process will need certain resources such as CPU time, memory files, input-output devices, etc. to accomplish its task. These resources are given to the process when it is created. In addition to the various physical and logical resources that a process obtains when it is created, some initialization data, like input, may be passed along. For example, a process whose function is to display on the screen of a terminal the status of a file, say F1, will get as an input the name of the file F1 and execute the appropriate program to obtain the desired information. And also, when you use a browser like Google Chrome, there is a process running for the browser program. The OS also has many processes running which performing various functions. All these processes should be managed by process management, which keeps processes for running efficiently. It also uses memory allocated to them and shutting them down when needed. The execution of a process must be sequential, so at least one instruction should be executed on behalf of the process. A process is a unit of work in a system. Such a system consists of a collection of processes, some of which are operating system processes. Those are executed system code and the rest being user processes. Those that execute user code. All of those processes can potentially execute concurrently. Now the functions of process management in OS or operating system is process creation and deletion, suspension and resumption, synchronization of processes, and communication between processes. Next comes this input-output device management. One of the purposes of an operating system is to hide the peculiarities of specific hardware devices from the user. For example, in Unix, the peculiarities of input-output devices are hidden from the bulk of the operating system itself by the input-output system. It also helps you to hide the variations of specific hardware devices from you, the user. Now, the functionalities of input-output management in operating systems are: it offers buffer caching system, it provides general device driver code, it also provides drivers for particular hardware devices, it helps you to know the individualities of a specific device. The next one is network management. A distributed system is a collection of processors that do not share memory or a clock. Instead, each processor has its own local memory and the processors communicate with each other through various communication lines, such as high-speed buses or telephone lines. Distributed systems vary in size and functions. They may involve microprocessors, workstations, mini computers, and large general purpose computer systems. Now, the network management is a process of administrating the managing computer networks. It includes performance management, fault analysis, provisioning of networks, and maintaining the quality of service. The computer in the network are connected through a communication network, which can be configured in a number of different ways. With the help of network management, the network can be fully or partially connected, which helps users to design routing and connection strategies that overcome connection and security issues. Now, the functions of network management are: distributed system help you to various computing resources in size and function. They may involve microprocessor, mini computers, and many general purpose computer systems. A distributed system also offers a user access to the various resources that network shares. It helps to access shared resources that help communication to speed up or offers data availability and reliability. The next one is main memory management. Memory is central to the operation of a modern computer system. Main memory is a large array of words or bytes, each with its own address. Interaction is achieved through a sequence of reads or writes of specific memory address. The CPU fetches from the stores in memory. In order for a program to be executed, it must be mapped to absolute addresses and loaded into memory as the program executes. It accesses program instructions and data from memory by generating these absolute is declared available and the next program may be loaded and executed. In order to improve both the utilization of CPU and the speed of the computer's response to its users, several processes must be kept in memory. There are many different algorithms depends on the particular situation. Selection of a memory management scheme for a specific system depends upon many factors, but especially upon the hardware design of the system. Each algorithm requires its own hardware support. It is costly and hence has a lower storage capacity. However, for a program to be executed, it must be in the main memory. Now the functions of memory management in operating system is like that. It helps you to keep track of primary memory, determine what part of it are in use by whom, what part is not in use, and in a multi-programming system, the operating system takes a decision about which process will get memory and how much. It allocates the memory when a process requests. It also deallocates the memory when a process no longer requires or has been terminated. The next one is secondary storage management. The main purpose of a computer system is to execute programs, isn't it? These programs, together with the data they access, must be in main memory during execution. Since the main memory is too small to permanently accommodate all data and program, the computer system must provide secondary storage to back up main memory. Most modern computer systems use disks as the primary online storage of information of both programs and data. Most programs like compilers, assemblers, short routines, editors, formatters, and so on are stored on the disk until loaded into memory, and then use the disk as both the source and destination of their processing. Hence, the proper management of disk storage is of central importance to a computer system. There are few alternatives like magnetic tape systems are generally too slow. In addition, they are limited to sequential access. Thus, tapes are more suited for storing infrequently used files, where speed is not a primary concern. The operating system is responsible for the following activities in connection with disk management like storage allocation, free space management, and disk scheduling. And the last one is security management. The various processes in an operating system need to be secured from each other's activities. For that purpose, various mechanisms can be used to ensure that those processes which want to operate files, memory CPU, and other hardware resources should have proper authorization from the operating system. For example, memory addressing hardware helps you to confirm that a process can be executed within its own address space. The time ensures that no process has control of the CPU without renouncing it. Lastly, no process is allowed to do its own input-output to protect, which helps you to keep the integrity of the various peripheral devices. Here, protection refers to a mechanism for controlling the access of programs, processes, or users to the resources defined by a computer, controls to be imposed together with some means of enforcement. So, protection can improve reliability by detecting latent errors at the interfaces between components subsystems. Early detection of interface errors can often prevent contamination of a health subsystem by a subsystem that is malfunctioning. An unprotected resource cannot defend against use or misuse by an unauthorized or incompetent user. Now we are going to discuss about the following common services provided by an operating system, which are program execution, input-output operations, file system manipulation, communication, error detection, source allocation, and protection. Now, what is program execution? An operating system must be able to load many kinds of activities into the memory and to run it. Its program must be able to end its execution either normally or abnormally. A process includes the complete execution of the written program or code. There are some of the activities which are performed by the operating systems are: it loads program into memory, it also executes the program, it handles the program's execution, and provides a mechanism for process synchronization as well as process communication. The next one is input output operations. The communication between the user and devices drivers are managed by the operating system. Input output devices are required for any running processes. In input output, a file or an input output devices can be involved. Input output operations are the read or write operations which are done with the help of input output devices. It gives the access to the input output devices when it is required. And the next one is file system manipulation. The collection of related information which represents some content is known as a file. The computer can store files on the secondary storage devices. For long-term storage purpose, examples of this storage media include magnetic tape, magnetic disk, and optical disk drives like CD, DVD. All you know that. A file system is a collection of directories for easy understand and uses. These directories contain some files. There are some major activities which are performed by an operating system with respect to file management. It gives an access to the program for performing an operation on the file. Programs need to read and write a file. The user can create or delete a file by using an interface provided by this operating system. The operating system provides an interface to the user, creates or delete directories. The backup of the file system can be created by using an interface provided by this operating system. Nowadays, you all know about what is communication, and here the communication is. In the computer system, there is a collection of processors which do not share memory peripherals devices or any clock. The operating system manages communication between all the processes. Multiple processes can communicate with every process through communication lines in the network. There are some major activities that are carried by an operating system with respect to communication. Two processes may require data to be transferred between the processes. Both the processes can be on one computer or a different computer but are connected through any computer network. The next one is error handling. Now, what is an error? An error is one part of the system that may cause malfunction of the complete system. The operating system constantly monitors the system for detecting errors to avoid some situations. This gives relief to the user of the worry of getting an error in the various parts of the system causing malfunctioning. The error can occur anytime and anywhere. The error may occur anywhere in the computer system like in CPU, in input-output devices or in the memory hardware. There are some activities that are performed by an operating system like it continuously checks the possible errors and also takes an appropriate action to correct those errors and consistent computing. Operating system also do the resource management. When there are multiple users or multiple jobs running at the same time, resources must be allocated to each of them. There are some major activities that are performed by an operating systems are all kind of resources using schedulers. CPU scheduling algorithm is used for better utilization of CPU. The next one is protection. The owners of information stored in a multi-user computer system want to control its use. When several disjoint processes execute concurrently, it should not be possible for any process to interfere with another process. Every process in the computer system must be secured and controlled. Now, one of the most important things in operating systems is the system call. Now, what are the system calls in operating system? The interface between a process and an operating system is provided by this system calls. In general, system calls are available as assembly language instructions. They are also included in the manual used by the assembly level programmers. System calls are usually made when a process in user mode requires access to a resource. Then it requests the kernel to provide the source via a system call. Now here comes one question, that what is kernel? The kernel is a computer program at the core of a computer's operating system. Can I make you understand what is kernel? So kernel is a computer program at the core of a computer's operating system with complete control over everything in the system. It is an integral part of an operating system. It is the portion of the operating system code that is always resident in memory. As can be seen from this diagram, the processes execute normally in the user mode until a system call interrupts this. Then the system call is executed on a priority basis in the kernel mode. After the execution of the system call, the control runs to the user mode and execution of user processes can be resumed. A computer program makes a system call when it makes a request to the operating system's kernel. System call provides the user the services of the operating system to the user programs via application program interfaces, that is API. It provides an interface between a process and operating system to allow user-level processes to request services of the operating system. System calls are the only entry points into the kernel system. All programs needing resources must use system calls. The services provided by the system calls are process creation and management, main memory management, file access, directory and file system management, device handling like input-output devices, protection and networking. Now, what are the types of these system calls? There are mainly 5 types of system calls. Now, those are explained in details as follows. The first one is process control. These system calls deals with processes such as process creation, process termination, etc. The next one is file management. These system calls are responsible for file manipulation such as creation of file, reading a file, writing into a file, etc. The next one is device management. These system calls are responsible for device manipulation such as reading from any device buffers, writing into device buffers, etc. Next one is information maintenance. These system calls handle information and its transfer between the operating system and the user program. And the last one is communication. These system calls are useful for inter-process communication. They also deal with creating and deleting a communication connection. Now, through this picture, you can understand very well how these system calls can work. The first one is process control. The function used in this process control is end and abort, load and execute, create process and terminate process, wait and signed event, and allocate and free memory. The next one is file management. The function used here are create a file, delete file, open and used file, read, write and reposition, get and set file attributes. The next one is device management, and the functions are request and release device, logically attach and detach devices, get and set device attributes. The next one is information maintenance, and the functions are get or set time and date, get process and device attributes. And the last one is communication, and the functions are create, delete communication connections, send and receive message, help OS to transfer status information, attach or detach remote devices. Now, some of the examples of all the above types of system calls in Windows and Unix are given as follows. For Windows, the type of system calls for process control are create process, exit process, wait for signal, object process. And for Linux is fork, exit and wait. For Windows, the types of system calls like file management is create file, read file, write file, close handle. And for Linux, those are open, read, write and close. For Windows, device management system calls are set console mode, read console, write console, and those are for Linux are IOCTL, read, write. For Windows, the system calls related to information maintenance are get current process ID, set timer, sleep, and those are for Linux are get PID, alarm, sleep. For Windows, the system calls for communication are create pipe, create file mapping, map view of file, and those are for Linux are pipe, shm get, mmap. There are many different system calls as shown in the table. Details of some those system calls are as follows. The first one is open. The open system call is used to provide access to a file in a file system. This system call allocates resources to the file and provides a handle that the process uses to refer to the file. A file can be opened by multiple processes at the same time or be restricted to one process. It all depends on the file organization and file system. Another one is read. The read system call is used to access data from a file that is stored in the file system. The file to read can be identified by its file descriptor and it should be opened using open. Before it can be read, in general, the read system calls takes three arguments, that is, the file descriptor, buffer which stores read data, and number of bytes to be read from the file. The next one is write. The write system calls writes the data from a user buffer into a device such as a file. This system call is one of the ways to output data from a program. In general, the write system calls takes three arguments. Those are file descriptor, pointer to the buffer where data is stored, and number of bytes to write from the buffer. The next one is close. The close system call is used to terminate access to a file system. Using this system call means that the file is no longer required by the program and so the buffers are flushed. The file metadata is updated and the file resources are deallocated. The next one is wait. In some systems, a process needs to wait for another process to complete its execution. This type of situation occurs when a parent process creates a child process and the execution of the parent process remains suspended until its child process executes. The suspension of the parent process automatically occurs with a wait system call. When the child process ends execution, the control moves back to the parent process. The next one is fork. Processes use this system call to create processes that are a copy of themselves. With the help of this system call, parent process creates a child process and the execution of the parent process will be suspended till the child process executes. The next one is exec. This system call runs when an executable file in the context of an already running process that replaces the older executable file. However, The original process identifier remains as a new process is not built, but stack, data, head, data, etc. are replaced by the new process. Next one is kill. The kill system call is used by OS to send a termination signal to a process that adds the process to exit. However, a kill system call does not necessarily mean killing the process and can have various meanings. And the last one, I'm telling you that exit. The exit system call is used to terminate program execution, especially in the multi-threaded environment. This call defines that the thread execution is complete. The OS or operating system reclaims resources that were used by the process after the use of exit system call. Now here comes the operating system structure. Operating system can be implemented with the help of various structures. The structure of the operating system depends mainly on how the various common components of the operating system are interconnected and melded into the kernel. Depending on this, we have following structures of the operating system. The first one is simple structure, next one is layered structure, next monolithic structure, and the last one is microkernel operating system structure. Now about this simple structured, layer structured, monolithic microkernel operating system structure, I am going to briefly discuss. The first structure is simple structure. There are many operating systems that have a rather simple structure. These started as small systems and rapidly expanded much further than their scope. A common example of this is MS-DOS. It is designed simply for a niche amount of people. There was no indication that it would become so popular. An image to illustrate the structure of MS-DOS is as follows. It is better that operating system have a modular structure, unlike MS-DOS. This would lead to greater control over the computer system and its various applications. The modular structure would also allow the programmers to hide information as required and implement internal routines as they see fit without changing the outer specifications. Next one is layered structure. An operating system can be broken into pieces and retain much more control on system. In this structure, the operating system is broken into number of layers, that is labels. The bottom layer or layer 0 is the hardware and the topmost layer, that is layer N, is the user interface. These layers are so designed that each layer uses the functions of the lower level layers only. This simplifies the debugging process as if lower level layers are debugged and an error occurs during debugging, then the error must be on that layer only as the lower level layers have already been debugged. The main disadvantage of this structure is that at each layer the data needs to be modified and passed on, which adds overhead to the system. Moreover, careful planning of the layers is necessary as a layer can use only lower level layers. Unix is an example of this type of structure. The next structure in operating system is monolithic structure. The monolithic operating system is a very basic operating system in which file management, memory management, device management, and process management is directly controlled within the kernel. As you can see in this picture, all these components like file management, memory management, etc. are located within this kernel. Now, what are the features of the monolithic operating system? Simple structure. This type of operating system has a simple structure. All the components needed for processing are embedded into the kernel. Work for smaller tasks. It works better for performing smaller tasks as it can handle limited resources. Communication between components. All the components can directly communicate with each other and also with the kernel. And the code to make monolithic kernel is very fast and robust. So the fast operating system is done here. Now what are the limitations of a monolithic operating system? Code written in this operating system is difficult to port. Monolithic operating system has more tendency to generate errors and bugs. The reason is that user processes use same address location as the kernel. Adding and removing features from monolithic operating system is very difficult. All the code needs to be rewritten and recompiled to add or remove any feature. Now, what are the examples of monolithic operating system? Some examples of monolithic operating systems are VMS, Linux, OS 360, OpenVMS, Multics, AIX, BSD, etc. The last one is microkernel operating system structure. This structures the operating system by removing all non-essential portions of the kernel and implementing them as system as user-level programs. Generally, they provide minimal process and memory management and a communications facility. Communication between components of the OS is provided by message passing. A microkernel is the minimal software that is required to correctly implement an operating system. This includes memory, process scheduling mechanisms, and basic inter-process communication. This diagram that demonstrates the architecture of microkernel is as follows. As you can see in this picture, actually. In the shown diagram, the microkernel contains basic requirements such as memory, process, scheduling mechanism, and basic inter-process communication. The only software executing at the privileged level, that is kernel mode, is the microkernel. The other functions of the operating system are removed from the kernel mode and run in the user mode. These functions may be device drivers, file server, application inter-process communication, etc. The microkernel makes sure that the code can be easily managed because the services are divided in the user space. This means that there is less code running in the kernel mode, which results is increased security and stability. Essential components in the microkernel are only the core functionalities of the system. A component is included in the microkernel only if putting it outside would disrupt the functionality of the system. All the other non-essential components are put in user mode. The minimum functionalities included in the microkernel are memory management mechanisms like address spaces are included in the microkernel. This also contains memory protection features. Process scheduling mechanisms are also necessary in the microkernel. This contains process and thread schedulers. Inter-process communication is important as it is needed to manage the servers that run the own address spaces. Now the benefits of the microkernel are as follows. Extending the operating system becomes much easier. Any changes to the kernel tend to be fewer since the kernel is smaller. The microkernel also provides some security and reliability. And the main disadvantage is poor performance due to increased system overhead from message passing. Now, one part of the most important things of operating system is booting. Now, we all know how to start a computer. When we start a computer, it takes some time, isn't it? When we start our computer, then there is an operation which is performed automatically by the computer, which is also called as booting. In the booting, system will check all the hardwares and softwares those are installed or attached with the system, and this will also load all the files those are needed for running a system. In the booting process, all the files those are stored into the ROM chip will also be loaded for running the system. In the booting process, the system will read all the information from the files those are stored into the ROM chip, and the ROM chip will read all the instructions those are stored into these files. After the booting of the system, this will automatically display all the information on the system. The instructions those are necessary to start the system will be read at the time of this booting. Now there are two types of booting. One is warm booting and another is cold booting. When the system starts from the starting or from initial state means when we start our system, this is called as warm booting. In the warm booting, the system will be started from its beginning state, means first of all the user will press the power button, then this will read all the instructions from the ROM and the operating system will be automatically gets loaded into the system. And another one is cold booting. The cold booting is that in which system automatically starts. Mind it, automatically starts when we are running the system. For example, due to light fluctuation, the system will automatically restarts so that in these chances damaging of system are more, and the system will no be start from its initial state, so may some files will be damaged because they are not properly stored into the system. The next topic is virtual machine. Now what is virtual machine? Virtual memory is a space where large programs can store themselves in form of pages while their execution and only the required pages or portions of processes are loaded into the main memory. This technique is useful as large virtual memory is provided for user programs when a very small physical memory is there. Now, a virtual machine is an operating system or application environment that is installed on software. which imitates dedicated hardware. The end user has the simple experience on a virtual machine as they would have on dedicated hardware. Specialized software called hypervisor emulates the PC client or server's CPU, memory, hard disk, network, other hardware resources completely, enabling virtual machines to share the resources. The hypervisor can emulate multiple virtual hardware platforms that are isolated from each other, allowing virtual machines to run Linux and Windows Server operating systems on the same underlying physical host. Virtualization limits by reducing the need of physical hardware systems. Virtual machines more efficiently use hardware, which lowers the quantities of hardware and associated maintenance costs and reduces power and cooling demand. They also ease management because virtual hardware does not fail. Administrators can take advantage of virtual environments to simplify backups, disaster recovery, new deployments, basic system administration tasks. Virtual machines do not require specialized hypervisor specific hardware. Virtualization does, however, require more bandwidth, storage processing capacity than a traditional server or desktop if the physical hardware is going to host multiple running virtual machines. Virtual machines can easily move, be copied, and reassigned between host servers to optimize hardware resource utilization. Because virtual machines on a physical host can consume unequal resource quantities, one may hog the available physical storage, while little IT professional must balance virtual machines with available resources. Now, there are some advantages and disadvantages of this virtual machine. The advantages are there are no protection problems because each virtual machine is completely isolated from all other virtual machines. Virtual machine can provide an instruction set architecture that differs from real computers. Also, it is easy in maintenance, availability, and convenient recovery. Now, the disadvantage is when multiple virtual machines are simultaneously running on a host computer, one virtual machine can be affected by other running virtual machines depending on the workload. Virtual machines are not as efficient as a real one when accessing the hardware. Hope through this video I can make you understand all about the structure of operating system. Thank you for watching. In my upcoming video, I will discuss with you about the next unit of operating system, that is process management.